Okay, so today's topic is about lenses. You've got two types of lenses. You've got convex and concave. Convex lenses are the ones that are thin on the outside and thick in the middle. These are your convex lenses. Concave is thick on the outside and thin on the middle, like this. Concave. So it's caved in. You can see that it's caved in. That's a good way to remember it. So the convex lens. Why do we even care about lenses? It's because they do different things to light. So if I've got light rays coming in from an object from a long distance, your convex lens is going to focus them. That's your focus, and that would be your focal length. So it's basically a magnifying glass. So if you're looking at an object, then it'll actually magnify the image. It'll channel all the light rays into a single focus. So, for example, if you hold a magnifying glass and it's a sunny day, you can channel all the sun's light into a focus through the lens, and you can actually burn something. Now, this is not recommended. Don't try this at home, but I'm just letting you know that you can channel all this light into a little focus using a convex lens. So the convex lens converges light rays. The convex lens converges light rays. What does a concave lens do? Well, if I've got the same light that's coming in parallel from a long distance, from a faraway object, like the sun, for example, then the convex lens is actually going to spread out. It's going to spread out the light rays. So a convex lens is going to diverge the rays, the light rays. Why do we care? Well, if we know what they do, then you can actually know which type of glasses to buy when you can't see short distance or when you can't see long distance. You can research this in your own time. There's myopia and there's hyperopia, and each one is corrected by one of these two lenses. But we're not going to go into that. We're going to skip to the types of images formed from these two lenses. So let's say you've got an object. And by the way, before we continue, I need to explain to you that light rays coming from a very distant object, they're pretty much parallel. The light rays coming from that distant object is parallel. Light rays coming from a close object is obviously spreading. And then you can ask, what do you mean light coming off an object? You know, objects don't give off their own light. You're absolutely right. Light comes from a light source and it reflects off the object, and then it reflects towards you, and you see what enters your eye. For example, right now, light's coming off the light bulb in the room, and that's hitting my face, and it's hitting the board. That light is reflecting into the lens of the camera, and that's the only thing you see. You can't see the light that's over there, otherwise the angle would change. So what you need to understand is when light enters through a lens, it changes what you think that the object is either closer or further or real or virtual. There are three different categories. So I'm going to show you what happens when light passes a convex lens, and then the same thing when light passes a concave lens. So let's say that the object you're looking at is, I don't know, a tree. So you're looking at a tree from a very far distance. That tree, light rays coming from that tree are parallel, and they're coming in this direction. What does a convex lens do? Remember, it converges. So it starts to bring the light rays together. So you have your focus here. And think about this light ray that's coming from the top of the tree. That light ray is passing through and it comes to this focus, and then what you see over here is going to be an upside down tree. So the light ray coming from the trunk of the tree actually flips after the focus, and now you see an upside down tree. But this depends on where you're standing. So if I'm looking through the lens at a tree, then if I'm standing in front of the focus, that tree is still going to be upright, right? It's still going to be upright. I'm still going to see the tree, but it's just going to be a very small tree. It's going to be small, but it's going to be upright. After the focus, the tree flips over. So technically, when you think about our lens in our eye, because our lens is a convex lens, everything we see should be flipped over, right? Everything we see is flipped over, and that's absolutely true. Babies, when you think about it, when they're discovering their hands, they feel very weirded out. They're tripping out. And the reason for that is because they're starting to see everything upside down. And it takes a while for the brain to reflip it. So yes, everything we see is flipped, is upside down, but then our brain reflips it. So there was a scientist who tried to play around with this, and he got glasses that flips everything upside down. So he started seeing everything upside down, and he put them on for like a week. And guess what? He actually got used to it. After a week of nausea and vomiting, he actually got used to where his legs are, and he started seeing everything the right way around with the glasses on. You know where the problem happened? When he took those glasses off. So now he had no glasses, he should be back to his own eyesight. Everything was upside down for him. Because the brain is so smart that it adjusts itself for whatever the situation is. So his brain, now that he took the glasses off, he started seeing everything upside down again. And then his brain had to readjust to that situation. It took him another week. And I don't think he recommended it to anyone. So it depends. Wherever you're standing, that's the type of image you'll see. So I'm going to draw the same situation with the concave lens, and then I'm going to explain these three scenarios. So let's draw the tree, and the light ray from the top of the tree is coming through, light ray from here is coming through. And remember, what concave does is it spreads out the image. Okay, but our brain wants to see a focus. Does it see a focus here? If you're standing here and you're looking through the lens, is there a focus? There's no focus. So the brain says, okay, I'm going to make my own focus. I'm going to extrapolate this line, and I'm going to assume that the object is basically over here. So what the brain's going to see is something like this. So the tree that the brain's going to see is going to be somewhere here. Wherever you're standing, you're still going to see a very tiny tree that's over here. So the definition of real and virtual, I'm going to explain it like this. If the image falls on this side of the lens, towards the observer, where I am basically looking through the lens, this is called a real image. If the image falls on this side, it's called a virtual image. Think about when you look at a mirror. I don't want to confuse you with mirrors, but when you look at a mirror, where's your image? Is it in front or is it behind? It's behind. And you can't actually touch your image. It's behind the wall. Now, that image doesn't exist because what's behind the mirror is just the wall. It's full. You can't actually go around and touch your image. So we call this a virtual image. So if the image falls outside towards you in the real world, and you think that you can actually touch your image like a hologram, that's what we call a real image. So when we are looking at, this is the object, I'm going to label this O, and this is the image, the object and the image. Now notice that I didn't do the image yet for the convex lens, and there's a reason for that, because it depends on where you're standing. So I'm going to give you two scenarios for the I'm going to give you three scenarios actually for the convex and one scenario for the concave. Because it's easier with the concave, I'll start with the concave. So if you're standing here or here or here or here, wherever you're standing, however far away, however distant you're standing from the concave lens, it really doesn't matter. Your image is always going to be on which side of the lens? It's going to be on the virtual side. So your image is going to be virtual. Now look at the second classification. Is it upright or is it inverted? So is the tree upright or has it been inverted? The tree is still upright. So we're going to label that as in the second classification as upright. The third classification says, has the object been enlarged or has it been diminished? And you can see over here that it's been diminished. So this image now has a classification of VUD, which is virtual, upright, and diminished. So wherever you are, every time you look through a concave lens, you're going to see a virtual, upright, diminished image. That's a little different to a convex lens, because if I'm standing over here between the focal point and the lens, I'm going to see a tree that's like this. I'm going to see a real image, obviously, because the image is falling on this side of the lens. I'm going to see a real tree. I'm going to see an upright tree. And I'm going to see a diminished tree. It's smaller than the object. Now, what if I was standing over, let's say here, after the focus? Remember, the tree actually flips over after the focus. So I'm going to see the tree like this. It's upside down. Now, this tree is the second scenario. If you're standing just behind the focal point, I'm going to see a real tree, I'm going to see an inverted tree, and I'm going to see a diminished tree. Okay. Now, what if I'm actually standing very far away? So if we continue that light. What if I'm standing very far away from my convex lens? What if I'm standing extremely far away from my convex lens? I'm going to see the tree looking something like this. So my tree is now real, it's inverted, but it's actually enlarged. It's larger than the object itself. So you have three scenarios of the type of image you're going to see when you look through a convex lens and an object. Three different scenarios, and it depends on where you are. So if you're close to if you're in front of the focal point, you're actually going to see a real upright diminished image. If you're just behind the focal point, you're going to see a real inverted diminished image. And if you're way far away from the focal point, you're going to see a real inverted enlarged image. And I'm going to show you this with actual lenses. So we'll start off with the concave lens. Hopefully this will make more sense. So the concave lens looks something like this. So I'll actually show you the lens. The lens is very thick on the outside, but it's very thin on the inside. It's very thin. So it's this lens over here. So if I do this, you're going to notice that. By the way, just a reminder, wherever you are, you're always going to see a virtual upright diminished image. And you should see that image of me when I do this. So I'm virtual, I'm upright, but I'm diminished. Look how small my head is compared to my head over here. I'm always going to be diminished. Doesn't matter how far away you are, my head's always going to be upright and it's going to be diminished. It's going to be smaller. So let's look now at the convex lens. So the convex lens looks something like this. It's thin on the outside, it's thick on the inside. And if we flip it, it's going to be, you're going to see three different scenarios. So I'm going to show you the first scenario where you're actually closer than the focal point. So like this. So notice that as I start pulling this lens away, as I pull the lens away, everything starts to enter this focal point. And everything starts to become weird. It's like becoming infinitely larger. And then suddenly, look what happens. Everything is inverted. So you're starting to see this section here.